Good morning, everyone. We are at the top of the hour, so we're going to go on and get started here. Thanks again for joining us for the webinar today. Our webinar will be 30 minutes along with time at the end for Q&A. During the webinar, you can send your questions through the chat icon, which is located at the bottom of your screen, and we will answer your questions during the Q&A portion at the end of our webinar today. We will be issuing PDH certificates for those attending the live session that have elected to receive them. And we'll also be sending a copy of the presentation that will be included in our post-webinar communication. All of our webinars are recorded and available on demand at bartlettwest.com. We will continue to add webinars in the near future, so continue to check out our website and look for some upcoming opportunities. Today, we're going to hear from Tyler Rimmert. Tyler is a senior group manager in the Rail group at Bartlett and West. He is responsible for the daily operation of a team of GIS professionals and understands accuracy and efficiency are critical in all projects. Today, he will be discussing how viewing all of your data as spatial data creates a common denominator. With that, I'm going to turn it over to Tyler to take it away.
Thank you, Rebecca. Can you hear me okay?
Yes, I can.
All right. So as Rebecca said, I'm a GIS production manager here at Bartlett and West for our Rail group. I also work as a project manager and a GIS solutions consultant for all of our groups, not just Rail. But if you haven't worked with Bartlett and West before, we serve a very diverse group of clients. We have utilities like oil and gas, electric power, regional water, groups like municipalities, tribal nations, higher education. We do work in the transportation space, so DOTs and of course rail. We also work in field services and construction phase services here at Bartlett and West. So oftentimes I'm called in to help our clients with not just one problem, but a group of problems. So my desk looks a lot like my client's desk, and it looks, this slide here is the best reflection of that, I think. I have this big mess of things that I need to manage for myself and for my clients in a day. Things like real estate, capacity planning projects, UAV and drone data, permitting easements, government compliance reports, long-range plans, environmental remediation and concerns, a really big dissimilar bucket of things that rattles around and can be very inefficient and overwhelming for a lot of people, especially if you've just stepped into a new role or maybe you're even new in your career. A lot of people solve these problems by throwing money at them, right? Getting some specialized software. So there's a lot of really great vendors out there that will sell you work order tracking software or dispatching software, or especially trouble ticket software. There's a whole lot of special software you can get out there to help you file a trouble ticket and receive a trouble ticket and manage a trouble ticket when it's done. Same with UAV and drone data. There is something new every day to help you manage all the data that comes out of a drone and keep track of your flights and things like that. But there's a lot of problems in this pile, and if we buy specialized software for each of them, firstly, it's expensive, and second, it's still not really organized. Your permit software isn't going to help you manage trouble tickets, and your trouble ticket software certainly isn't going to help you manage your drone program, really. And so putting all of this work that we do together in a cohesive fashion becomes really difficult. It makes things inefficient and very unorganized. So I am usually brought in to come up with some approach to make sense out of all of this and solve this problem. So if you're like me, a couple months ago, you were teaching third grade math at your kitchen table. This is Clearly not third grade math. In fact, I don't recommend doing any of this math this early in the morning here. But it's a good example of finding a common denominator. That's something that we teach folks even as far down as third grade, that to simplify a very complex problem, we need to make everything the same somehow. And so you can see right about here, things start to make slightly more sense, or at least get a little bit shorter. We've got the 1/2 figured out here, and we're starting to make all of the dissimilar mess that we had above look the same on both sides here. And they've repeated that all the way down until they came up with some math that even I can do, which is -1/2 plus 1/2 equals 0. The common denominator has helped them solve what at first glance was a very difficult problem. And the word jumble that we just saw, we're going to approach that problem the same way. Everything that was in that jumble of unorganized things that we need to manage in our day had one simple thing in common, and that's location. Location is going to be our common denominator. And if you learn anything today about how to streamline the work that you do or make it more efficient, it's that I would suggest and recommend that you approach the insurmountable problems in your day with the idea that this is a location problem. All of the things in that word jumble happen somewhere on this earth. Probably 99% of it is associated with some kind of location. Uh, Approaching the problem with that common denominator of location lets us bucket up a whole bunch of that word jumble into some more easy to manage things. Several of the things in that jumble were events. That's something that happens at a location. So that could be a pipe leak, an outage, a derailment, the flight of a drone. So that's things like trouble tickets, work orders, asset replacements. Those events all happen at some place. Another very popular bucket that we could pull out of that word jumble is telemetry. That's information that comes in from a sensor of some sort in the field. That could be meter readings, stream gauges, pressure sensors, even equipment trackers, so things like fleet tracking devices or even crew tracking devices. Another popular bucket is area of interest, or AOI. That's a really fancy way of saying that we're just going to draw a box around a very important place on the map. We've got a work plan or a project site or a zone of some kind that is important to us that we need to keep track of. Um, Finally, I guess there's more buckets, but probably the one of the most important ones is what I call reference materials. That's things like imagery from a drone, that's paper maps of any sort, and a very popular one, the CAD file. Almost everyone here is probably using CAD in some capacity, and a lot of times when you run into a GIS person like myself, they are trying to convince you to throw your CAD away and move on with GIS. And I am pleased to say I'm not going to be that guy. I think that you should keep using CAD if it makes sense for you. MicroStation and AutoCAD are both awesome products, and they've got some really important things that they can do, right? Like if you are figuring a super elevation on some kind of 3D design for transportation, you've got me beat in the CAD space as compared to GIS. But after you're done doing your engineering in CAD, we can definitely bring that into a GIS and use its location as a way to add it into the picture of all the data that we have. That's things like your pre-design, so 10%, 20%, 30% design, and even as built or other things that you get after you're finished building. They still have a lot of value, and there's a lot of great reasons to still do that in the CAD space, but when you're done with it, remember that work happens at a location, and that we should view it like the rest of our very difficult to organize things. We should view it as a location and bring it in. What we really want is to create a system of record, a geographic information system, a GIS, a single database that can hold all of the varieties of information that we are working with and trying to organize, not 6 separate pieces of special software where this is trapped over here behind a wall and this is trapped over here, but all of our location data together. So this is from an actual client project here. Some of the things in this database are recognizable. There's some buildings here clearly, and in green it looks like there is some sort of green space, some planters, dividers, where something is growing. The rest of this data, you could use your imagination, could be almost anything. The lines could be irrigation pipe, and some of the dots could be sprinklers. These could be gas lines and valves. They could be overhead electric and lights. They could be almost anything, but right now they're just location data. They're points and lines and polygons. What really turns them into something is adding attributes onto them. So if we add a pipe diameter to one of these lines, it becomes a pipe. If we add conductor information to one of these lines, it becomes a power line. And so location in a GIS lets us build a system of record, one big database where we're going to store all this stuff. And if you don't have one of these now, this is the first place where you get to make some decisions that could impact how efficient and how streamlined your work will be. Bartlett & West is a SQL shop. We use SQL here in our office, but we support clients with a flexible range of different databases. You may have heard of Oracle Spatial. That's a pretty popular one. One that most folks haven't heard about yet, but is definitely out there, is SAP HANA. And each of those has something that they're really good at, right? So SQL is a Microsoft product, so it's very integrated with Microsoft platforms, and almost all of us are using Microsoft Office in some way. So SQL is really good that it integrates well with Microsoft products. Oracle Spatial is fantastically complex, and it can be super accurate. It can store very detailed information, and Oracle Spatial also has an amazing set of checks that it can do on the database side in the database that can help assure the quality of the data that you're putting in there, that you're filling out all your attributes, and that the location information that you put in there is as precise as it can be. SAP HANA, if you've never heard of it, is specifically designed for what they call big data or telemetry systems. That's millions of readings from sensors coming in and being analyzed and crunched and even just stored. With big data, that's the very first problem, right? Is receiving this huge torrent of data and storing it somehow. You could even go a step further and consider some things like the cloud. If you're a very small shop, there are ways to build a system of record that's cloud-based. That would use something like Azure or Amazon Web Services. There's quite a few of those to choose from. For a smaller shop, a business or an enterprise that's less than 10 people, you don't want to get hung up doing Windows updates, and you don't want to have to buy a whole server and manage all of its wiring and permissions and stuff like that. For a person that has a smaller organization, the cloud can be a really awesome way. Another great thing about the cloud, especially in this day and age, is that everyone's kind of working from home or is very distributed. The cloud obviously facilitates people working remotely or having access to that thing from a variety of places. That's where we get into a system of engagement. This is the two main classes of folks that we have touching our system of record. We have a person in the field and a person that is way too happy to be at work this morning in the office, typing in the air conditioning on a keyboard. Oftentimes, this step here, the engagement part of our GIS and location data problem, is where I find the most inefficiency and the most opportunities for streamlining. In almost every case, when I arrive at an organization, the field person and the office person are doing duplicative work. The person in the field is filling out a paper form and sending it into the office, where the person in the office takes the form and retypes the whole thing into a computer. That's the very first method of duplication that we see, the first inefficiency that we run into. How are we going to streamline that? How are we going to make it more efficient using location as a common denominator? The first thing that we can do is focus on having the person in the field, the person that's actually there, the person that actually knows what's going on and understands what actions have been taking place. We want that person to put in the data. We need to get them digitally enabled. They need a tablet or a laptop or a cell phone or something so that they can input the information that they need to input and send it to the office. The person in the office needs to be doing something better with their time. They need to be coordinating the movements of all the people in the field. They need to be ensuring that the data coming in from the field is high quality, that it makes sense, that nothing is missed, that they're getting the information that the organization needs to carry out its tasks. Often what we start with most times is, let's replace a paper form with a digital form. I just showed you a GIS map slide back there, and a lot of people rush right into, let's get this person in the field a map on their tablet. If they've been filling out a paper form for 35 years, they don't need a map. They might need a map, and if they do, if it makes their job easier and better and makes the data they submit higher quality, we can get them one. But if they've been filling out a paper form for 30 years, let's focus on just getting them something that looks like a form so that their job doesn't change significantly, with the exception of it's digital now instead of paper. There are a lot of places where having a map makes it easier. Maybe instead of typing out what happened, they can just draw a line on a map and we're good. But for the most part, if they're used to filling out some kind of paper form that is a report of the work that they've done, adding a map into that is just overwhelming. It's complex, it's new buttons, it's too much. It gives them access to data that seems good to a person in the office, but actually is of little use to a person in the field. You get a lot of options here, both for the person in the field and the person at their desk. Obviously, the world market leader in GIS software is a company called ESRI out of Redlands, California. And they have a lot of awesome products that you can use in the field, like ESRI's Collector, or at your desktop, ESRI's ArcMap or ArcPro. But there are some ways that these two folks can engage in our system that doesn't have to be ESRI software. So Microsoft Power Apps and Microsoft Flow might let you write some things that lets the person in the field put in information, or the person in the office move a little faster and more efficiently. They could even type some things into Excel tables. It's not our favorite. I would prefer it to be a database table of some kind. So maybe we step up to a web form that's been custom written that submits to a table in an Oracle database or something. But they could interact with a table depending on the kind of data that they need to put in. If they're just typing in customer addresses, a map might be helpful, but really, as long as we get the address information, they don't need a map to make their day more cumbersome. If we can get the field to office phase of our work at a minimum made completely digital, it opens up a lot of amazing new things that we can do to streamline and make this more efficient. We get automation and assistance. So I use three main I guess, milestones to see if we're ready to do that. Is our work digital? Is our work repetitive? And is any part of our work calculable? So it's just like a math formula or something. If it is, there are a lot of things that we can do to make the field to office flow more efficient. We can write scripts, we can build support tools in the map or in the form, or we can use our database to enforce some of the information that we're putting in. This is another one of those places where you'll run into a lot of computer consultants that will tell you, we can automate these 2 people out of a job. That's always everyone's first idea, is that we can write a script that will just make one of these 2 people go away and our life will be so much better. I'm here to tell you that it is far better for your organization to support these people with automation and scripting than it is to replace them. People have a place in this chain. They make decisions that computers cannot, and they can use intuition sometimes to solve a problem more quickly. There's new studies out there every day that will tell us that a human and an artificial intelligence or a script, machine learning, working together are far superior than an artificial intelligence by itself or a human by itself. So I'm always looking at ways that I can help these 2 people do their job more efficiently. That doesn't mean occasionally we find some task that we can entirely get rid of and have a script in the background crunch it all out for you. But the goal shouldn't be that we're going to replace these people. It should be that we're going to help them. And as they are each putting information into this system, we are going to arrive at a single point of truth. Our system of record becomes the nexus for all the stuff that we have in that word jumble. So here's that same map again from a project that we worked on here at Bartlett and West. And it looks a little crazier now. Now we really do have water lines and power lines and irrigation lines, and I'm told there's even a sulfuric acid line in here. That's really a thing. All in this one system. For just a minute in this view, that can seem very overwhelming by itself, almost as bad as the word jumble that I have on my desk here in the first slide. But we can filter this out. So a water person just sees water and a power person just sees power. There are, excuse me, lots of reasons why you might need to see all of this at once. If you're going to dig a trench through here for some reason, you're going to need to know that all of these lines are here, that they all exist. You need that awareness as you make that plan. In this case of this particular client, each one of these colors of lines was a separate CAD file. They updated each one manually. If they had something they needed, they would oftentimes print it and send it out to a person who would mark it up and then send it back, and then they would draft it back into the CAD system. And if they needed to, for instance, dig a trench through the middle of this property, laying all of the CAD files on top of each other wasn't always the easiest thing to do. It could be done, but they're maintained separately, and it wasn't really an idea that we would stack them all up and look at them all at once. With a system of record, the single point of truth in the GIS, we can do this, and we could, instead of mailing out a map and having it marked up and sent back, we could publish this as a form, an app, or as a map that other people can use and consume, and they can see as little or as much of the information as they need to get their job done. So at this point, we can store the data, we can edit it, and we've got this fantastic amount of location data all in one system. The next step is being able really to act on it. This is where we get a lot of our return on investment. We need actionable insight from the system. So GIS is wonderful in that it can display 2D, 3D, even 4D data. In this particular case, we worked for a client. They've got 1,000 radio towers. Each one of these is a radio tower here. And these radio towers communicate with a piece of equipment that passes through here. And the person in charge of maintenance for these radio towers wants to know if any of the radio towers are bad. The radio towers, remember, he's got thousands of them, send data to the office every 5 minutes. If we put all that into a database, in 2 weeks, we amass several million records. Doesn't take long. That's an overwhelming amount of data. At this point, even with all that data, really all the maintenance person can do is say, is it on or is it off, right? In this 4D view, we've actually taken a week's worth of readings. Each cube is a day or so, smashed together, and we've displayed it. So early in the morning on the first day, you can see these 3 towers here had a low report. This one's red, here's a yellow, and here's a yellow. We've even got one tower that didn't report at all. So is this one bad? Is this one necessary? That's another thing that we could ask ourselves. This is something they could go look into. Are these 3 towers bad? They certainly were early in the morning on the first day. It's also possible that the piece of equipment that ran through here early in the morning on the first day had some sort of problem. Maybe the tower's fine because later on it's reporting green. So maybe we should go find the piece of equipment that passed through here at 8 a.m. on Monday, and we should have a look at it to see if it's got some problems with its radio or telemetry systems. The rest of these are all reporting sparsely, but they are, when they do operate, they're reporting fine. We've got green, 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 green. We've got another one that received no report, which is kind of strange because the towers around it all have quite a few reports in on them that they're visualizing. So we've just turned 2 million records taken over a week or two into an actionable insight. We don't need to run down this line and check every single tower. We need to go look at these 2 that did not report. We might want to, while we're in the area, check these 3 here that coincidentally had bad signal, but we've also determined that maybe the piece of equipment that ran through here was bad, which means we should go look at it. Actionable insight is really what we want, a fast and easy actionable insight for people that make decisions in the office to consume and decide how to proceed. Besides visualization in GIS, another really popular way to get actionable insight is the dashboard. We see them everywhere. Unfortunately, with coronavirus, this is one that most of us have seen. This is one of the first dashboards published from our friends at Johns Hopkins, showing data from all around the world. Treating your problems as location data and putting it into a dashboard is a great way to streamline the consumption of it and end up much quicker at actionable insight. The dashboard has a great collection of things it can show. It has a map, doesn't have to, but it can. It's got some graphs, which are also very useful. And it's got some raw figures in here in math. Since all the data in our system of record has a location, we can take all the dissimilar things and make any kind of dashboard we need out of it. Where are my crew? Where's my equipment on a map? How many trouble tickets do I have open? How many permits have they secured, or how much land have we acquired for a new easement? The good thing about dashboards is that they're almost always real time. As soon as someone puts information into your one single point of truth in the GIS database, this thing updates, and you always have the very latest in information at your disposal. So dashboards are a really good way to streamline things. As usual, you get a few options for making dashboards, right? You could always code your own from scratch, but ESRI has a product they call Operations Dashboard, and that's what's been used here. But a lot of people are also familiar with Microsoft's competing product, Power BI, and Power BI lets you make a fantastic amount of reports in a dashboard style, and they can consume a lot of information besides just GIS repositories. Since it's Microsoft product, it's integrated with everything in Office, and we can pull in a lot of information from a lot of dissimilar places to help us make comparisons and help us arrive at some kind of action. What we really want, though, the absolute best, most streamlined, most efficient way that we could have our answers is Ubiquitous GIS. That's a map that you never see. If you think about Captain Picard in Star Trek, he walks into the bridge and he sees some crazy alien business on the TV there, and he says, "Computer, what am I looking at?" And the computer gives him an answer. He doesn't log into anything. He doesn't type anything. He doesn't have to search anything up or build a query. He just asks a question and he gets an answer. I had a system like that at my previous job. Her name was Gladys. She was thrice semi-retired. And if you needed to know anything about the network where we worked, you went in and you asked Gladys, when did our first meter go in? She'd tell you, October 1942. And you took that answer. You didn't have to Google anything. You didn't have to know anything about computers. You just had to know that Gladys had all the answers. When I came to Bartlett and West, it was interesting. My first 3 clients each had a master archivist, and that master archivist, coincidentally, they were all named Ray. I don't know why, but each one of my clients had a guy named Ray, and he did the same thing. If you wanted to know how much property you owned in Louisiana, you asked Ray. If you wanted to know how many signal bungalows were out there on the system, you asked Ray, and he had an idea. Probably wasn't exact, but you took that answer no matter what it was. There's problems with that system, right? Gladys is finite. We will only have Gladys here for so long. And Ray is not scalable. Once you ask Ray a question, he would go on for 3 hours about property in the parishes of Louisiana. So if you get 3 or 4 or 5, 6, 7 people down there with questions, there's going to be a long line of people sitting in chairs waiting for Ray to give you an answer. If your enterprise is any sort of appreciable size, it just doesn't work anymore. Since we have all of our location information in our GIS, we start to approach some things like that, Ubiquitous GIS. Maybe as part of our automation, a report lands on your desk every Monday morning that has just the information you need. To you, it looks like an Excel spreadsheet that gets emailed to you. You don't have to, you would never know if you didn't know that behind the scenes, a very complex geographic information system was putting all that information together for you. We can even approach some things like natural language. We all hope to have Captain Picard's powers here with Google and Alexa and Siri that we can ask a question and just get an answer. A lot of GIS systems, very complex ones, are really approaching that. Dashboard is a very close example of that. It's real time, it has information on the screen, and you get answers instantaneously. And if there isn't a map on your dashboard, you might not even understand that a GIS is running behind the scenes to make all that possible. So we can fix this. We can make it more streamlined, more efficient, the data itself, as well as all the practices and processes that make it possible. The first step is to choose to view your problems as location plus some attributes. Think about your system of record, how we're going to bucket up our events and telemetry and reference materials. Really think about your system of engagement, because that is where most of your inefficiency is coming from. We need to remove duplicative editing. We need to reduce users to just what they need in the field and office. And if we can, we need to assist them in completing their tasks using automation and scripting. Then we can work on getting actionable insights for our enterprise from all that. We need to synthesize and present complex or dissimilar data. We can visualize it in 2D, 3D, and 4D, or we can visualize it in real time as a dashboard or a report. And then the real goal is Ubiquitous GIS. Most of us can approach it. Some of us will even achieve some of that, and hopefully you won't even see the GIS anymore. So that's my talk for today. I'm gonna stick around and answer questions in the Q&A. If you've got some specific questions about your industry or your workflows, or just more general questions about the things we've discussed today, I'll be here, and Rebecca might have some more for us. Rebecca, anything else we need to know?
Thank you, Tyler. As he mentioned, go on and drop your questions into the Q&A portion. You'll find the chat window at the bottom of your screen. We'll wait a couple minutes for questions to come in, and while we're doing that, I want to thank you again for sharing your time with us today, and thank you, Tyler, for sharing your expertise with us. Just as a reminder, a recording will be available on our website at bartlettwest.com. Tyler's contact information is provided here. As he mentioned, we encourage you to connect with Tyler directly. And so we'll just wait here a couple minutes to see if there are any questions from our attendees today.
I guess I'll also mention I'm also on LinkedIn, so if you prefer to visit with me that way, you're more than welcome to look me up there, and I'd be happy to continue the conversation.
All right, I am monitoring the chat window. I don't see any questions at this point. Thank you, Amber. That was my next question. Is the chat window for sure working? So thank you for confirming that. Amber, I greatly appreciate it. Thank you to Sam as well. As Tyler mentioned, feel free, find him on LinkedIn, contact him through the contact information there. And he would be happy to answer any questions you may have as you continue to think through and process some of the information that was shared with you today. I don't see any questions, so I'm going to wrap up our webinar for today. I want to wish you a fabulous day, and we look forward to seeing you again soon. Thanks again, and take care all.